15 minutes. See if I can make this video in 15 minutes. Okay, I'm going to get 2 new parent functions today. We're going to do a square root and a cube root. Pretty easy. Think about this. If you're going to graph this, then we've got to be dealing strictly with real numbers. We don't want any negatives under that square root, because if we have them, we're going to have imaginary answers. Also, this is a principal square root. Is it A-L or L-E? Ooh, I'm not sure. I'm going to say principal square root. I'm not sure which one it is. I probably should look that up. So this is a function. There's only the one answer. So if you can't have negatives, think about what your domain is. It's x better be 0 or bigger. It's got to be 0 or positive. It's got to be a non-negative number. And if you plug a 0 in and you do the principal square root of 0, you get 0. Okay? If you plug a 1 in, do the principal square root of 1, you're going to get 1. To get another integer out, you got to go to 4 before you're going to be up 2. Then you'd have to go to 9 before you're up 3. And so it just continues to grow. It just grows slower. It's something called concave down that you'll learn about in calculus. But that's the graph of it. I probably should try to at least go through the points. And then just looking at the graph, the range or the y values are always greater than or equal to 0. Okay? All right, now if you do a cube root, though, your domain can be anything, because you can take the cube root of negatives. You can take the cube root of positives. You can take the cube root of 0. And if we made a T-chart for this, let's say we start at 0. Cube root of 0 is still 0. Principal cube root of 1 is still 1. We'd have to go to 8 before we'd be up 2. So over here, like those 2 points stay the same, but we have to go all the way to 8 before we were up this far. Okay, if you went the other way, the cube root of negative 1's negative 1. And the cube root of negative 8, it's negative 2 if we're dealing with just the real numbers. You'd have to go all the way to 27 and negative 27 before you'd be either up 3 or down 3. So the range also could be any real number, because it's going to keep rising. It just rises even more slowly than the square root one did. Okay, and then we're just going to take and do everything with transformations that we already know and apply them here. So if you've got the square root graph, you think about the parent function, and then we're going to move it 3 places to the right and up 4. So that point right there, 0, 0, if it goes 3 places to the right and up 4, it's going to sit right there. I'm going to plug in a 3 and check it. Like if I plug in a 3, 3 minus 3 is 0. The principal square is 0, 0. 0 plus 4 is 4. And then I'm not stretching it and I'm not shrinking it. I'm not flipping it upside down or anything like that. So it's the exact same shape. So you know how we were over here, we went over 1, up 1. So we'll go over 1, up 1. And then we went out 4 before we were up 2. Oops, pretend like that lined up there. It did not. But so if we go over 4, up 2, then we'll have the shape of this graph. And we can double check. Like this is putting it at 4, 5. So if I plugged in a 4, yep, I get out a 5. This is, let's see, I went 4 ahead of 3. So that'd be 7. That's principal square root of 4 is 2 plus 4 more. Up 6, yep. So I'm over 7, up 6. So my domain, x can be anything greater than or equal to 3. And the range is y can be anything greater than or equal to 4. And think about the domain. Like without having to draw a picture of it, we could have looked up here and said, okay, what causes the problem? As far as graphing is concerned, imaginary numbers cause the problem. So I would need that radicand to not be negative. So let's write it that way, which would mean it needed to be 0 or bigger. So algebraically, we could have gotten the domain too. I still think I always contend that the range is easiest with a graph. Okay, All right, so this one's a cube root. Oops. So you think about that parent function from the first page. It's like that. We're going to go 2 to the left and down 1. So take that point right there, 0, 0. Go 2 to the left and down 1. And then that's going to be that point right here. And then we're going to go over 1, up 1, down 1. And then we went all the way to 8. So 2 and 6 more before we were up 2. 1, 2, 3, 4, 5, 6, 7, 8 before we were down 2. And you get a graph like this, and we can double check our points. Like I'm saying, there's one at negative 1, 0. Negative 1 plus 2 is 1. Cube root of 1 is 1. 1 minus 1 is 0. It's looking good. I'm saying right there, there's a point at 6, 1. 6 plus 2 is 8. Cube root of 8 is 2. 2 minus 1 is 1. It's looking good. Right there, I've got one at negative 2, negative 1. Negative 2 plus 2 is 0. Cube root of that 0. Take away 1. Yep, I'm feeling really good about these. Put a negative 3 in. Negative 1 minus 1. Yep. Put a negative 10 in. Looks like I'm down 3. Negative 10 plus 2 is negative 8. Cube root of that is negative 2. Negative 2 minus 1 is negative 3. You can also think about, here are the points on the parent function. What are they? 8, 2, negative 1, negative 1, negative 8, negative 2. And we said go down 2. Oh, sorry, left 2 and down 1, right? Well, left and right affects the x. So it's like take the x value and subtract 2. Take the y value and subtract 1. Oops, I'm up there too close to the corner. It won't right. So take the x and subtract 2. Take the y and subtract 1. That's another way of doing it. Like you could do that to all points. Okay. This one takes that just square root function, flips it over the x-axis. So it's just a reflection about the x. So it's just going to go like that. Oops. So 0, 0 still in there. Oops. Over 1, down 1, over 4, down 2, over 9, down 3. So the domain is still x needs to be greater than or equal to 0 because of right there, but the answers are less than or equal to 0. Okay, take that cube root. Looks like that. We're going to move it up 4 places and reflect it about the x-axis. So I do, like I told you when we first did this, I always do anything that affects its shape first and then its orientation. Or either way, those I do those first. So I'm going to turn it upside down, reflect it over the x, and then move it up 4 places. So 1, 2, 3, 4. So that's that point right there. And then 8 up 2, 8 down 2. I should get a shape that looks like this. And I can double check. I'm saying I got one at 0, 4, plug in a 0. Yep. I've got one at negative 1, 5. Negative 1, that's 1 plus. Yep. I've got one at negative 8, 6. Negative 2, opposite that's 2 plus 4, 6. Yep. I'm looking good. And then 8, 2. Domain, all real numbers. Range, all real numbers. I can get out any positive, any negative. I can plug in any positive, any negative. Or 0 and get out. All right, this one, we're going to take our square root parent function. We're going to stretch it vertically. So it's going to grow twice as fast, and then we're going to move it down 7 places. So this point, it's going to go down 7 places. So 1, 2, 3, 4, 5, 6, 7. And then we're going to stretch everything vertically by a factor of 2. So on the regular square root function, I went over 1, up 1. Now I'm going to go over 1, up 2. I'm going to take all those y values and double them. So if I go over 4, where I used to go up 2, now I'm going to go up 4. And when I was over 9, square root of 9 is 3. Double that, I'm going to go up 6. 1, 2, 3, 4, 5, 6. I should have a shape like this. And let's double check. 0, negative 7. Yep, that holds. 1, what are we at? Negative 5. Okay, so square root of 1 is 1. Times by 2 is 2. 2 minus 7 is negative 5. Yep. This one's at 4, negative 3. Principal square root of 4 is 2. 2 is 4. 4 minus 7 is 3. Yep. Over 9, I'm down 1. Principal square of 9 is 3. 10 2 is 6. 6 minus 7 is -1. Good. So domain's still right there. X has to be greater than or equal to 0. But as far as looking at it, my y's are always greater than or equal to -7. Any more? Oh, yay, one more. Almost got done by 7. Okay. This one, we're going to shrink it vertically. So all the y values are going to be half as high as they were for the same x movement. On a cube root, so we take their regular parent function, and then we're going to move it up 7. Okay, so cube roots, let's just go ahead and get this out of the way. Domain range, you can do anything and get out anything. So we're not flipping it upside down. So we're going to take that point, move it up 7 places, puts it there. All right, now where I used to would have gone over 1 up 1, I'm only going to be half as high. And then where I would have gone over 8 and been up 2, I'll only be half as high. And then the same thing coming this way. Oops, it's a little more than half down. And then like that. So it sort of flattens out even more. It grows even more slowly. It grows actually half as fast as it did before. Okay. And I'll double check my points. I got one at 0.7. That holds. I've got one at, 1.7 So 1/2. Yep. I've got one at 8. 2. Yep. I've got one at -1 6.5. That holds. I've got one at -8 6. So -2, half that's -1. 7 plus -1 is +6. Did I say -6? I feel like I said -6. I didn't mean to. All right, there we go.